All right, well, let's go ahead and get started because we want to make sure we have enough time for questions and discussion. So thank you there's so many wonderful sessions. Thank you for being in this one. My name's Christine Kirkpatrick, and I am so happy to be chairing our session. Maybe you could, to the people in the back, you could put up, well, maybe you're testing things, but you could put up the title slide again whenever you're ready. I especially want to thank everyone who came from far and near, our colleagues who could have been out enjoying Brisbane, but instead created talks for you to enjoy. And then my colleagues Phil and Padu, who are online, who are on the East Coast of the US, staying up very late. And so I really want to thank both of them. I'd also like to start out by acknowledging the First Peoples of Australia and the Kumeyaay people, where my home institution is, and we thank them for their stewardship and their nurturing of the environment and their decisions past that make it such a wonderful a present here for us to enjoy. So as I mentioned, Christine Kirkpatrick, I'm Secretary General of CODATA. I'm also co-chair of the U.S. National Committee for CODATA, and I'm also on the advisory board for the Academic Data Science Alliance, which is an organization of data science institutes and now AI institutes around the globe. The data science and research data communities share many common goals and challenges, but despite this, the communities tend to have separate venues for convening, membership, and even educational tracks. And this is something that was really, I want to credit Phil Bourne, who inspired this session. He's also been part of ADSA and the U.S. National Committee. And so the U.S. National Committee's really rallied around this concept, and that's why we proposed this session. And we're so thankful for our international collaborators to give us a full perspective. When I was thinking about how to frame this, I had some other slides I was going to show you, and then in the interim, Mark Musin, my colleague from Stanford, who's here, he's here all week, and he's running for the executive committee for CODATA. He had a quote from his blog that I thought was spot on. He said, "The essence of science is data, and data science is central to science. But most scientists view data science as the analysis of data without consideration of where the data come from, how they're managed and communicated. CODATA focuses on challenges and faces a lot of challenges educating the scientific community about the full spectrum of data science and the important role that all of us can play in enhancing data infrastructure at a global scale." And so that's what we're really here to learn about today, is how do we bring these two groups together. We have 5 short talks, and then we'll have a moderated panel and Q&A. So I'll ask you to hold your questions to the end, unless it's a burning question, so that we make sure we have enough time for all the presenters. Okay, so with that, I'd like to invite my good colleague, Leo Lahti, who's a data science professor at the University of Turku in Finland, and also a fellow member of the executive committee of CODATA.
Hello, good morning everybody. It's a pleasure to meet you, and today I'm going to tell you a little bit about my approach to data science, a topic that is very close to my heart, which is the methods of data science. So that's why the title, From Observation to Interpretation. Data is observation, but methods are interpretation. This work is based and derives from my work at the University of Turku Department of Computing, as well as our national policy work on open research methods by the Federation of Finnish Learned Societies. We recently developed national guidelines or national policy on open research methods, and this is very much inspired by the ideas I present now. So let us briefly look at the structure of typical scientific process. So when we discuss data, we also have to think about the methods that we use to interpret the data, and then ultimately to communicate the findings that we do based on these methods. In practice, these elements are inseparable, and usually this is an iterative process. So when we learn more about the data using our methods, we may revise the methods, we collect more data, we update and enrich the data, we apply the revised methods, we communicate, we discuss, we share this with the scientific community, and the research goes forward. So these elements are indeed inseparable in the scientific process, and often you cannot really completely distinguish these from each other. I already mentioned this iterative nature of this process, so that's another aspect. So we have to think about the life cycle of the research process. This life cycle starts from the initial idea, spans to the data collection, initial pilot experiments, and the final communication. And very often, especially nowadays, even after publication, the research methods and data are being updated. So the data science methods and infrastructures play a very central role in this process, and that's why I put them here in the middle. So now, what is the role of openness in this? By improving the openness of data and methods and communication, we can make this process not only more transparent, but also more efficient, more reproducible, and something we can build on, something that drives research forward. There are, of course, many practical challenges when we think about how to make this more open. So, are we talking about individual methods or the whole workflow of research? Are we talking about technicalities like open licensing or open sharing infrastructures? And can we require the same level of openness for all research outputs? That is, of course, a question of the resources as well. It is much easier to share some raw source code that we use to interpret the data than prepare a fully reproducible and open software. So resources will determine a lot on the level of openness that we can use for the open research methods. And of course, this is all also related to the culture of openness. One challenge with the culture of openness is that the digitalization has brought so many new challenges. The data sets are more complex, the methods are more complex, and it has become more difficult to communicate how we do the research process. So there has been, of course, a lot of research, as we know, on the different problems related to the reproducibility of research. This is just one recent example from economics papers, where they gave the same data set and the same task for a large number of different analysts, and they all obtained different results and sometimes different significances, even different effect sizes for the same task. So no single analyst achieved exactly the same conclusions. And this is very typical for data science, and this is not a problem as such. I think what is more important is to realize that when we apply research methods on data, it is always an act of interpretation. And in science, we can give different interpretations for the same data. What is essential is that we make this process transparent and something that we can criticize. And that's how science goes forward. So what is the role of data science communities on this? So I'm part of global developer communities such as Bioconductor. Bioconductor is one of the largest bioinformatics projects globally. It has been around for 25 years and now has more than 2,000 high-quality open-source software libraries for life sciences, and the number is increasing. There is also annual conferences in North America, Europe, and Asia, and this is really a thriving global community of not only developing research methods, but also providing training and documentation on this. So data science communities that develop and use methods play a key role in making data alive. So we can share data, we can talk about sharing open data and research data, but we also need to talk about the openness of the methodology that we use to interpret the data. Because this is what really makes the data a living entity and the process a living process. In these kind of communities, the ideas can thrive and develop, and we can we can make science better. So Bioconductor is just one example. There are many other data science communities doing similar things, like our OpenSci is one, but around many different languages we have examples of this. So these kind of communities are essential part of the current data science practice. So in Finland, we recently developed a national policy on open research methods. You can find it from this website address. And this open research methods policy is basically having a closer look at the different ways we can approach research data. This is challenging because there is so many different types of research methods, ranging from experimental to theoretical research to quantitative to qualitative research and mixed methods. But in general, we have been discussing the challenges here. And the motivation for opening up the research methods is to increase the quality and impact of research. So openness as such is not the end goal, but openness is a means to increase the quality of research and the impact of research. And there are, of course, many different aspects of these, as you can see on the slide. And I think that as scientists, we are responsible for aiming at high quality and high impact research. So that's my short overview about the role of methods and data science in these communities, and I would like to finish with this slide. A quote that says that what marks out modern science is not the conduct of experiments and collection of data as such, but the formation of critical communities that can critically assess discoveries and replicate results. And it has been said that this is what separated science from alchemy in the 16th and 17th centuries, and now the open data science communities play a big role in realizing this. Thank you very much.
Thank you so much, Leo. And now I'd like to invite Daphne Raban up. Yeah, this is our goal, right? To not be the family of alchemists, right? To be the family of scientists. Okay, and Daphne's here representing the Israeli National Committee for CODATA and is also running for executive committee member for CODATA.
Thank you, Christine, and thank you also to Leo for discussing the human aspect of data science, which is something I would like to bring up in my talk as well. So good morning or good noon to everybody. The topic of my talk is the role of data stewardship. Okay, thank you. The role of data stewardship in research and in data science. And in fact, in Israel, we are quite behind on this topic. So I come to you with, I would say, theoretical knowledge, but not practical knowledge in this domain. It's, for us, still a hopeful vision for the future. I brought a simple definition of what is data stewardship that I just copy-pasted from Wikipedia. Data steward is an oversight data oversight or governance job or role within an organization, and data steward is responsible for ensuring, excuse me, I'm still jet-lagged, the quality and fitness for purpose of the organization's data assets, including the metadata for these data assets. So quite a dry definition there from Wikipedia. And I found more inspiration by a quotation by former CODATA president Barend Mons from the Netherlands, who said, it is irresponsible to support research but not data stewardship. Okay, he said that researchers spend up to 80% of their time on what he called data munging. I had to look up what data munging actually means, and it means damaging the data. So he says researchers actually spend up to 80% of their time data munging, and so data stewardship is so essential. So it's a fairly new role within organizations to be a data steward, at least to my knowledge. It has a research orientation because of the focus on data quality and integrity and on looking on the whole data cycle. And I'll relate to both of these terms in a second. So it's exciting because it's a fairly new type of position. It's essential. And while everybody's talking about elimination of jobs due to AI, here we see the growth of a new and fascinating role for the future. So many researchers still face the fact that data are fragmented, poorly documented, and difficult to reuse, and they spend, like Bar and Mons said, a lot of time cleaning and organizing the data and often recreating stuff that already exists. So data loss is a big stewardship, and here is where data stewardship comes in order to be kind of a bridge. Christine talked about creating bridges. So data stewardship is a position to create that bridge between data and between the scientists who need the data. And data stewardship talks about responsible data management throughout the life cycle of the data, making it fair, and considering the ethical aspects as well. I find it interesting also in terms of my own research. This is research that I'm not presenting in this conference, so I just took one slide. My area of research outside of CODATA is information economics. And a study I did in the recent months is about the perceived quality of information, and we found, in fact, that data quality is the #1 attribute that people seek when they think about the quality of information and when they even consider paying for information. So data quality, as I wrote in the bottom, in the sea of information, it's all about data quality. It's of the utmost importance, and this is empirical data from an experiment with more than 300 participants. So this will be coming up pretty soon in the scientific literature, I hope. Whoops, why isn't this going forward? Okay, another thing I wanted to relate to is a report that I was honored to be part of the group writing it, and I will be presenting it in this conference on Thursday. The report is about data science education, so again relating to Leo's talk, and this report is actually a practical suggestion of how to implement data science to non-data scientists in various disciplines. And we've heard in many lectures in the past few days how necessary this is. So expanding a little bit, I'm sorry, this again is from the report on data science education. So the report stresses the data cycle itself and the components of the data cycle itself, which are mainly related to the data, but it's important to acknowledge, again, the human side of it. So here I took from an article that was recently published a much more elaborate definition of what a data steward is, and I don't want to go into too much detail. It's beyond the scope of a 10-minute talk. Just to say again that the data cycle focuses on the data itself, while stewardship adds a human and a managerial dimension. So the data steward needs to be involved in all those stages of the data cycle that we've seen before, and this is spelled out in all these jobs here that appear on this detailed slide. worldwide, again, not in Israel, unfortunately, we see data stewards working in various kinds of domains, be it e-commerce or be it government or be it in the health and life sciences. So we do see the growth of data stewardship in various areas of the economy, but not in all countries equally, which is a job for us maybe here in CODATA and RDA to go on and cultivate and develop. These are just 2 slides with too much information about the underlying problem, which is the data quality problem that I've alluded to in our research, which said that data quality is the #1 issue for us to direct our efforts at. I think also the keynote of this morning related very seriously to data quality. I think Anna was the speaker who talked about data validity, right? So this all feeds into the same theme. And again, the human and managerial aspects of data stewardship. So coming towards the close of this short talk, data stewardship has an important human aspect, okay? Or it adds the human dimension to data science, and it takes us from the maybe objective domain to the more subjective domain. Data stewardship would benefit from interacting with various stakeholders in the data cycle, be it data engineers and data scientists, as in item 1 here, or interacting with more customer-facing people, such as marketing people, and product managers in companies. And another aspect, or another human aspect of this data stewardship role, is to provide guidance and training to others within the organization in various modes and forms of science communication, which is also something that was mentioned this morning in the keynote. Because I also function as academic head of the library in our university, I have to have the library in the story and in the picture. And the library is actually I would say, a natural place for data stewardship to occur, because in fact, many libraries host many databases, and they also, some of them train librarians to be data librarians. And like the library, like the academic library, data stewardship is fundamental to research in all areas of science. It is an integral part of the library's work, okay? And it's also fundamental to all areas of academic teaching, as I've alluded in that report. So we see the coming together of research and teaching via the library, which is a central body within each academic institution, right? So the centrality of the library is synergetic to data science, and this is why I think it has a pivotal role to play within the data stewardship framework. So with that, some takeaways. I think I've exhausted my time. And so it's an upcoming profession. It requires a combination of an inquisitive mind and attention to detail, would benefit from the human connection, from the managerial connection, and from interpersonal communication, and it would benefit a lot from the library connection. With that, I thank you for your attention.
Okay, well, and now I'd like to invite our speaker, Phil Bourne, who's online. Let's see, obviously I'm not good at doing two things at once. Okay, who's online, and he's going to share his own slides, but we do have his slides locally if needed. Phil Bourne has many titles. He'll introduce himself. Let's see if I can get a few of them right. He's Dean of the School of Data Science at the University of Virginia. He was previously the Chief Data Science Officer at the National Institutes of Health. gosh, so many things. Well, I should not steal his thunder. I'm sure he wants to talk about some of these roles, but we are so happy again to have him on the U.S. National Committee, where he has been a great connector to the data science world.
Thanks, Christine. Can you hear me okay? Just give me a thumbs up.
Perfect.
All right, lovely. I'm sorry I can't be there in Australia, so it's a shame that I couldn't get back. The timing just wasn't right. As Christine alluded to at the beginning, this nexus for this session was essentially based on some discussions we had in the US National Committee. My take on it all, and it's good that we're looking at this bridge, but my take on it all personally is that, and what sort of got me engaged enough to think about what we might do about it, was that I was struck by how we were operating in parallel universes. And I'll indicate what I mean by that in now. So as Christine mentioned, I'm actually the founding dean of the first School of Data Science in the United States, and also on the National Committee for CODATA. And I've had a long history, you can tell by looking at me if you can see me there, caring about data, particularly biomedical data. And I've been struck, and we've already heard a little about this, and I'm just really enforcing that from a data science dean's perspective. There seems to be a lack of alignment between organizations that care about data and the next generation of students who are studying the science of data on all it yields. And I say that for the following reasons. Here's an example of our own school. It's not there to impress you with numbers, but what it is to say is, as an example, we have, in our undergraduate minor, we have 678 students doing it right now across the university. It's by far the biggest minor in the university, and it has students from every single major in the university, from religious studies to economics to healthcare to you name it. So there's just a stunning student interest in data science right now, in part, of course, because that's where they see the jobs. However, here's the thing. Virtually none of those students, at least in our school, and I would say that it's fairly true generally, graduate or undergraduate, and the faculty that teach them have even heard of CODATA, RDA, AWS, or International Data Week, et cetera, et cetera. Now, I appreciate that efforts are underway to address this situation, but it seems like there's a massive disconnect here that, and I worry about it because the next generation, the kind of students I just pointed to, are going to be leading the charge. And having them much more integrated with the wonderful work that goes on in these organizations would seem to be really important. So I'm obviously looking at it from a data science perspective. Just to get how we got here based on that, is we raised the issue at the US National Committee for CODATA. That led to a virtual brainstorming session amongst a set of emerging leaders, where the folks from CODATA, myself included, were basically just listening to what these young emerging leaders had to say. And at the end of that, it was a highly energetic, and Rainey Acosti, who was the wonderful person who organizes all these sorts of things, in the years that she's been in the National Academy of Science, Engineering and Medicine, it was the most energetic meeting she'd actually been in. So there's lots of synergy there to be captured and lots of energy. But, how do we move forward together to address some of this at the international level? So that's sort of, that's the question. So I was compelled after that to write a blog about these parallel universes, and I just put up a QR code if you want to go read it. I'm going to essentially tell you pretty much what there is to say about it. The basic premise is that I'm characterizing much of what is being discussed and dealt with by organizations like CODATA and RDA and WDS as data engineering related to storage, sustainability, metadata, FAIR principles and quality of data and so forth, the kind of thing we've been hearing about. interestingly, that's going on. It's wonderful. Data science, I would characterize a little differently, and Padu will probably have something to say about this as well afterwards. But in a way, what we're trying to do with data science is to take advantage of all of the things that are being done in data engineering, but really don't know anything about how it's being done and by whom. And so I think that connection, and there's still so much data out there that they still spend, and it was, Baron Mons and many other people have said it, and I've observed it, that the students in data science spend about 80% of the time wrangling before they get to integration and discovery. And that's to me the essence of the data science. It's really about the integration of disparate data to actually come up with new discoveries that would not be made by one data set alone or in one discipline alone. And the focus of a lot of these data science initiatives, whether they be schools, departments, institutes, whatever they might be, is really geared towards societal outcomes, which is, I think is a really noble and important set of issues. So the question then is, with this basic premise, how do we bring things closer together? How do we essentially have the data engineers and the data scientists appreciate themselves more? And I think there's three elements to it, and we've heard a bit about it already: awareness, education, and collaboration. So the first step, of course, this is sort of a new set of principles. It's like awareness is like, the equivalent of find and fair. So how do we increase awareness? So what part of the problem is data science really does not have a global representative body. It's fragmented. Christine mentioned the Academic Data Science Alliance, but that's still, relatively small and very US centric, but it's there. So there are bodies out there, but they don't have the international capabilities of the kind of organizations that are represented at your meeting there. So how do we do better? My thought is we should select a few representatives with geopolitical variation and approach them about joint meetings and so on. This is actually already going on discussion between, say, for example, CODATA in the US and ADSA, but so much more needs to be done across these different organizations to bring people together. There's so much to be learned from each other. And I think there's a virtuous cycle there, and I'll get to that at the end, which I'm almost at. Second thing was awareness. First thing, regional engagement. So without being international, there's also a lot of many fast-growing, as you've seen from my own instance, schools, departments, and they get together across, for example, in Virginia, where we are, and Purdue is, we have regional meetings. And so there's the opportunity to engage at a more regional level. And national committees can have a role to play here. And then data science institutions need a touch point. They need someone who's an advocate for the work that are going on that is overseen in a way by CODATA and the other and RDA and so forth. So with awareness comes education. I think that there needs to be more awareness across the board as data science is evolving for how we think about the data itself. So to understand that, you need to look at data science curricula. They're changing dramatically in the era of AI. There's just no question about that. And so I think that kind of understanding. So there's a synergy that could be achieved there. Modules that integrate with existing data science programs. There's nothing really taught, at least we're currently talking about having more data engineering in our programs. But right now, there's really not a lot there. And it's an opportunity to insert, and I know there's some of this going on through the international bodies, but there's much more needs to be done. Data science faculty needs to be the ones to actually get on board with this. So having workshops with them. And then, of course, engaging the students. That's where the energy is. That's where the future is. There's so much to be had there. And they would be excited to participate. So, and then the final thing I'll say is really I think there's a virtuous cycle between data science methods and data engineering needs that I think is not that explored at the moment. We just had a meeting on biological data sustainability. I actually chair an international committee that's looking at that. And it's a serious issue, trust me. But what was presented at this meeting from a number of major biomedical data resources in the US was how AI is impacting what they're doing with respect to data engineering, particularly in the form of curation. And that's only going to increase, and I'm sure many of you are involved in this. So a lot of those methods are being developed in the data science realm, so there's something to be learned there. But also the feedback loop from how well they're working or not seems to me to create a virtuous cycle that could be really useful. And so we need more open data from data science. There's plenty of that. And because open has come up a number of times in the previous two talks, I will just say that within our school, we have a policy. It's an open data policy, or it's an open research policy, I should say, where faculty have the option to opt out, but they're automatically opt in. So their promotion and tenure depends very much on their open scholarship. So it's a way to control things, at least at an institutional level. And so I think there's much more can be done here, and I would love to hear your thoughts on it. And with that, I will stop. Thank you.
Thank you so much, Phil. A lot to talk about and discuss in the next portion of this. But next, I'd like to invite my good colleague, Padmanabhan Seshaiyer, who's going to share his slides, although I can also share if needed. He should be on Zoom there. He also has many titles, but I came to know him through my work with the National Academies, where he is the chair of the Board on International Scientific Organizations, which is the umbrella group where the U.S. National Committee historically has fit in for CODATA in the United States. Can you hear us, Padu? Oh, let's see. There are your slides.
Yes, I can. Yes, I can. Can you hear me?
Yes, and now we can see you. Okay, perfect.
Great. Thank you very much, Christine, and thank you to the previous speakers because they've set the stage for what I plan to share. So something different that I plan to share is how can this be brought much earlier? You know, while we talk about postdocs, graduate students, even undergraduate students, how do you actually get high school students and even earlier get them excited about data? And I'm going to share some of the perspectives. So because awareness can actually be, the earlier we do it, the better it is. So I was asked to talk a little bit about some of the work that I'm doing in that space. But I am the chair of the Board of International Scientific Organizations, although the National Academies is going through some changes, and this particular board oversees multiple U.S. national committees. One of the committees I chaired prior to this was the mathematics instruction, and which is different from CODATA. So once I transitioned to become the chair of BSO, one of the first things that we did with CODATA is we ran like brainstorming sessions around how do we use data as a theme for all the USNCs. So USNC is US National Committees. There's one for geology, one for physics, one for chemistry, one for mathematics instruction, mathematics. And so, but all of them use data. So we wanted to kind of brainstorm with all the chairs of the USNCs. And some of the things that you're seeing here are from the responses from the chair, and clearly talks to what Phil was talking about: awareness, access, advancing real-time tools to national security. So those were the things that came out of the chairs. These are all of the chairs of the different national committees. So what I wanted to talk today about is K-12, which is remember our high school days. So I'm going to start with high school. So if you all recall this from your high school, I'm sure you all remember your teacher asking you to write a 2-column proof to prove, two of those triangles where you have a perpendicular bisector. And if you're standing on the perpendicular bisector, you're equidistant from the endpoints. And we all actually proved it, and but we never asked the teacher, why am I learning this, right? But it was on the test, so we had to learn it. Of course, when you go to the test, they don't really ask you theorems. They ask you applications sometimes and say, find all those things. And we forget using these theorems. We just use some other things like Pythagoras theorem, and then you realize, why did I ever learn these things? I'm going to tell you a short story before I start, and then I'll tell you why I'm telling you the story. So if you recognize this man, this person, you may, and he's responsible for that street map that you see here. And that street map has typical streets in Soho, London, along with these black dots that you see here, which must surprise you. You must wonder what those black dots are. And this person, of course, is Sir John Snow, who actually mapped Soho, London, when there was the cholera epidemic. And he noticed that, for example, this black bar that is long is 18 people who died in a household. So clearly, this was the way he visualized data. This is in 1850s, okay? And no computers, no calculators and all that stuff. This is how they used to visualize data. For example, John Snow. Now, of course, he also noticed this is where most people died. But his challenge was to argue, which is another important thing in data science, is to argue effectively. But he was arguing that the disease actually transfers through water. But none of the doctors wanted to believe that, because the doctors thought, wait, this has to, water has to do with urination, fecal. So they had a theory that it was because of toxic air, so miasma. And so he had to prove it. And guess what he did? He went and saw that there were water pumps at many of those places where people died. And then he used something ingenious, basically the perpendicular bisector theorem. Remember from high school geometry? He actually calculated how many people walked equidistant to those pumps. And lo and behold, he found that one of the pumps, Broad Street Pump, was actually closed, and that stopped cholera. If you did not know the story, you at least learned it today. But then, of course, we can teach students about simulations. That's the last thing I want to teach. As Phil was saying, let them discover first, and then all these things are just simple tools. You can teach this in 5 minutes. So the purpose of telling you this story is the following. So in the state of Virginia, Virginia is the first state in the country, maybe in the world, to have created its own standards of learning in high school. So today, there is a high school course that I helped to lead for the state of Virginia, which is taught in 128 high schools this past semester. And that's because, of the excitement, and same type of excitement that Phil is seeing on the college side, the same type of excitement is happening at the high school side. And the students not only explore data, they take a local context, they follow a data cycle, which takes them through collecting and acquiring data, cleaning and processing data, interpreting, visualizing data, modeling, analyzing data, and then, validating and predicting with it. And communication is a big piece, ethics is a big piece. So every student has to do a capstone project through this course. This is a formal high school course that actually counts towards a mathematics credit. Now I'm helping other countries actually build something very similar, same type of ideas. So what we saw was not just the student excitement, but teachers are excited. These are mathematics teachers. We had 30 teachers in 2022, which became 60 teachers in 2023, which became 130 teachers in 2024. In 2025, I had 175 teachers. So what's happening is teacher interest is growing up. So obviously the student interest is also growing up, and they want to do real projects. And so we have created a new post-secondary pathway for students who are now looking at UVA type schools as really, where they want to go. And so these kids that are joining college are now much more data savvy than the typical freshmen that are joining college. So examples of student projects, students going to local airport and actually optimizing, using data to optimize when planes are taking off and landing, and optimizing the times and giving a letter, and they're going through data and context, communication, modeling, bias, computing. This is what the high school kids are doing. They're also taught to not just, we don't just teach them R or Python, but actually we teach them no code, which is CODAP, which is a common online data analysis platform, to a low code, to a high code. High code will be R and Python and all that. So we make sure that it's tech agnostic and the students are able to access whatever, their division allows them to do. And once they get excited, and then they go to higher levels of coding and all that stuff. And we also, teach them neural networks and machine learning. This is a paper that teaches them how to use certain differential equations and, systematically breaking it down using literate programming. Now, this has helped to just us receiving a $2.8 million grant to actually set up a special school for rural and rural fringe school districts in Virginia, in west part of Virginia, Shenandoah Valley, where faculty, students, teachers work together on mentored research, industry recognized credentials, and also apprenticeship programs. And this is with many, many school divisions that have no access. So they, data science is brand new to them. What type of research comes out of this? Here is a high school kid that's, went to MIT and other, and then at right now at a very prominent institution with full ride, already published 4 journal publications, 2 in Q1 journals, 1 in Q2, 1 in Q3. This is a high school student we are talking about. That's what is coming out. They're using data for infectious diseases, for example, combining it with domestic violence. So can you believe students? This is what students are interested in. So what we are trying to build is pathways that connect local community priorities and trying to get them interested in, different things, whether it's college pathway, whether it is workforce and so on. And this is becoming very popular, and lots of states are now turning in this direction. And here's another reason why. January 2025, the Future of Jobs report was published, polling 14 million people from 1,000 different companies from 50 different job sectors. Top job, big data specialists, fintech engineers, AI machine learning specialists. Now, here is the surprise for you. The core skills that came out was not just technology literacy and AI big data, analytical thinking, resilience. That's what they're looking for. So we ended up deciding, this is my last part of the talk. So we ended up creating a new framework. A new framework is called CRISP. CRISP stands for Culturally Relevant Instruction and Sustainable Pedagogy for Data Science. And we specifically combined some of the very popular frameworks, PBL, as in project-based learning, where student voice is central. And we combined it with a 5E instructional framework, which is how do you engage students, explore, have them explain, have them elaborate, and have them evaluate. We combined the two things. And then we actually added the data science lifecycle on top of it. And then we added a sixth E called expand to outside context. So for example, civic engagement. And the problem, believe it or not, the students chose, we exposed them to the sustainable development goals. They chose goal number 16, peace and justice, and they chose gun violence. Now, today's kids are not looking for textbook problems. They are looking for problems that they can make an impact on. So the data that they collected was from gun violence, the data archive. The questions that they asked was there a spike in mass murders? Well, which state is having most? And explain, illustrate. So they bring the data cycle into a context that they want to, make contributions to. And of course, their big question was, is high school bullying a predictor of mass shooting? Okay, thank you very much for this opportunity. So my point here is we tend to teach too much of content-based skills. We need to go beyond that to teach them competency-based skills like data competency, data literacy, so because today's students are not just consumers of education, they are producers of information. Thank you very much.
One last presentation, last but not least, and then we're going to spend the rest of the session in discussion. So I'd like to welcome up Kelsey Druken, who's here as one of our local people. And I'll let you introduce yourself while I open your slides.
Lovely. Thanks, Christine. And thank you, everyone, for your time today. I'm Kelsey Druken. I'm an associate director at ACCESS-NRI, which is one of our Australian national research infrastructures. We are a software and data infrastructure looking after Australia's climate modeling, software, and data capabilities. So I'm going to give a little use case story. And this is very much around one of the issues highlighted in the session description here, which is about bridging those gaps between best practices and then infrastructure practice. And so I'd like to walk you through one of the big things that we're focusing on how we help improve basically data management and data stewardship for our research users or end users in general of climate modeling software or products, and how we're trying to help make their end research and work with climate modeling data or outputs easier. All right, so just quickly, because we all use sort of similar words, but sometimes in similar, different ways, I'd like to just orient, your headspace and thinking for a moment in the climate modeling world to just walk you through what some of our workflow or our key workflows look like. This is very simplified, of course, but basically we have equations describing, the physical state that get approximated and turned into numerical simulations that are run on HPC infrastructure. This generates very large outputs that also are stored on HPC infrastructure. There's analysis that goes on those outputs, again, requiring supercomputer support. And then we have different visualizations, products, and derivative products that come from these modeling climate simulations. So because of that complexity, ACCESS-NRI, the ACCESS model, is an infrastructure to support this ecosystem. It's a framework. You can think of each little bubble on the screen as different code bases that are written and supported around the world, but they come together to be pieced together to basically provide these computer simulations. And ACCESS-NRI looks after how we curate and support this software and data ecosystem for the Australian context. So in terms of our opportunity here as an infrastructure, we look after both this software and data workflow, and we realize that we have an opportunity to help uplift the fairness of our outputs, because we have that sort of curation role from both the software perspective and the data perspective. And we wanted to basically operationalize as much of the data management components as we could into our workflows, take that off our end users. Several drivers for us were obviously basic user experience. So we want people to be able to use the climate models. We want people to trust this. The chain of where climate modeling data, the integrity of that is very crucial, especially in the current climate that we're in today. And as an infrastructure, we also were motivated because we want to reduce the support and overheads on our side as well. And then we had timelines with big international projects. CMIP7 is one here that also was motivating us. So the current state for ACCESS models are that we have native output coming straight off these simulations. You can think of this similar to satellites producing their raw level output. There's use cases where this needs to be slightly processed, and then others that want an even further process. So we have these different derivative products, and this is still based within the HPC platform. And curation, standards, consistency basically improve as you go to the right, but the time and effort as an infrastructure also increases the further you go to the right here. And this can be a problem because not everyone has that time, whether it's the data management role, whether it's the end researcher trying to get their data published through papers and meet FAIR guidelines. So this is where we've stepped in We have certain challenges that we know we need to address. These post-processing steps to create these different derivative products are not simple, and there's the human intervention factor. So just the implementation of standards and best practices can be inconsistent even when you're following the same standard. So just that human interpretation of what standard A means in practice varied even just across our community. So these were some of the things we hope to address. And at the end of the day, for us, really, we didn't want to just be catering to users that had that previous knowledge. We wanted any new user to come in and benefit from the data management investment, basically. Okay, so really quickly, our approach through here was to obviously go and consult our community. We recognized that we had different use cases across just even our local community, where some people wanted the native output, some wanted that slightly processed version, others definitely wanted the higher, very highly processed. We needed to consult people that were on that software end with the modeling teams. That's our own organization, some of our partners, the end user requirements, of course, and then just some of the physical requirements of the infrastructure. So that's on our side with how we're going to, pipe things together, manage the software, manage the data curation steps, how we help enable that data publishing pipeline. And with all of those things, in summary, this is very high level, but we noted that, okay, there's a few dimensions here around that standardization and consistency that are very low-hanging fruit. If we can just address a few of these, we'd make a huge step change and difference for our users and for our infrastructure support. And what we noticed across those three different outputs, really the main message here is that there's a lot of X's. Things were not consistent, and we could definitely make an improvement. And of course, if we think about that bridging education and help for users, a lot of these steps are often secondary, which means it's on the end researcher or user to do themselves. And again, that's a big ask often, and something that gets dropped or done, not as thoroughly as even the researcher intended, but everyone is time poor. So we wanted to basically aspire to be like the highly processed versions of the output, but try to get that embedded closer to the native output. And so this is what we focused on in this example of some of our work, and we reduced it down to say, let's try to ignore needing to even have a lightly processed version. And for us, in the climate modeling world, we deal with big, petabyte scale outputs, so actually reducing a copy of data was very advantageous as well. And so, so the key here is that we wanted to embed and automate the data management as much as possible in that first native output step. And we started by looking to see what else is done, and of course we look for guidance from other best practices around communities. A big one for us is a CMIC activity. You don't need to worry about the acronym, but this is a big international effort in the climate modeling space, and they've done a lot of work here, so we looked to grab as much as we could from what goes on for the very highly processed output and tried to translate what we could for the lower native output level. And essentially, where, the Venn diagram here of all these requirements, what we could support, our time, our staff, we found a place to start. So we're in the phase right now of applying this into our workflows, and the goal here is that this native output will meet very basic but important and vital foundational standards and quality at that native output level. We're able to embed this into our software workflows, which has the benefit of providing checks that we can verify for validity of both our software practices, but then also our end data outputs. So it's a small step, but very important, that we'll see benefits through our infrastructure, as well as, of course, for end researchers and users. I won't go through every single detail here, but from our end, the benefits, again, hit many dimensions. We will have a standard, specification for native output, which actually surprisingly doesn't exist. It's very much focused on that highly processed version, so this is a gap that we're able to help improve, particularly for Australia's code, improve user experience, lower support overheads, like I mentioned, and future-proofing climate software is a really important one for us as well. So my final summary here is that this was a quick, very simple version of the story of our journey here on Uplift through the software and data perspective. Our ideal, of course, is that we'd have FAIR automatically embedded across all of our software components, have a single version of output that would meet all user needs. So this is our unicorn that we're aiming for, but the practicality and the reality here is that it's actually a painted horse, and we're okay with that as a first step. It's a big jump to do it all at once, and so this is just our journey and approach here into this important space. So thanks for your time.
Okay, awesome. Thank you so much for everyone's attention, and to the speakers for 5 wonderful talks. So now I'd like to transition to the portion where we have a little bit of Q&A, and we'll take some questions from the audience after we get warmed up. So if I could invite Daphne, Kelsey, and Leo to the front, and if we could put up Padu and Phil on the screen. And thank you so much for staying up late. Yeah, by this time for you, I'd be in my pajamas, so I'm really appreciating your energy and that you're not in your pajamas. It's amazing.
We spared you that.
Okay, yeah. So actually, I'll start while we're assembling up here. If I could throw Phil a first question. So I always like to think about visions of success. So Phil, let me ask you, if these parallel universes came together, what would success look like, and what would the impacts be?
Yeah, so I think what it would look like is I think it would accelerate what we're already doing. So, if you spend 80% of your time right now data wrangling, I think is and munging, words that are being used. If that was reduced to say 10%, and then you had another 70% of your time to actually think about and action the integration, the processing, just the analysis, and therefore the outcomes, it would be huge. I mean, it would improve scientific productivity immensely. Ironically, in some ways, I think that's what AI is doing at the same time. And that actually is both a positive and a negative. And we're having lots of discussion about how AI is generating output, which then is finding itself back into data resources and polluting those resources, which of course is a serious issue. So, but at the same time, it's also accelerating a lot of things that we wanted to do that we couldn't really do in the same way before. So, long story short, cut down data wrangling to a fraction of what it is now, and spend that time on discovery.
That sounds pretty good to me. I think we'd all like, to spend less time doing what feels so clerical once you know how to do it. Okay, let me open up that question to others on the panel. If you'd like to comment on what would success look like if the data science and research data management communities came closer together. Oh, and microphone might help
too. I'll add a quick comment. From my perspective, I think, I guess just looking at how much time goes in to the full kind of curation cycle, recognition for time that goes into all those parts. I feel there's some gaps in our approach for research, our recognition for career progression and reward. So that having another lens to look at that, I feel would have many benefits to our broader community.
Thank you. I was talking about open research methods, and maybe part of the recognition could be also recognition about developing methods and using methods to interpret data, so that we could promote the communities who are actively using the data. I think that's a very important part, and this could help to promote data research management.
Yeah, I perceive your question as more of a question of harmonizing between the two organizations, right? And so each of us has his or her own lens, and I think that looking at the role of the data steward is kind of a central role that is common to people of both organizations, and could be a common goal that would create better harmony and synergy between them.
And Padu, no pressure, but if you'd like to comment about what success
Yeah,
might look like.
yeah, no, I think I agree with everything that everyone is saying, but I you know, Phil may not have referred to it, but one of the things they talk about at UVA is this value, right? So the data is used for the public good, you know, so it's not just a corporate asset, you know, so it's very important. It is to solve community. It's like, you know, and when that happens, when a global crisis like that happens, everybody will come together, you know. So I think that's my perspective on this.
Thank you so much. So I'd like to open it up to anyone on the panel. Is the situation in your country different? Well, and I guess we know Padu, Phil and I can speak for the US somewhat, but maybe to those assembled here in the front. Do you have are these communities closer together in your country, or is it essentially the same? Are these communities distinct? Or do you see ways they could align based on what's happening in your country? Well, I think we're here because we have a lot of questions and there's opportunities. But
Okay, I can start. I think it's difficult to talk about these communities as if they were two communities, because we have so many different subfields of data science. So we have life scientists, social scientists, and even within these we have many different areas that hardly communicate with each other. So I think we also need to take into account that this field is fragmented in this way. What to do about it? I will think a moment, and I will give this for others.
Yeah, I agree with Leo that there is a lot of fragmentation that's disciplinary, actually, based on the prior disciplines. And what I see, at least in Israel, is another fragmentation between the professional data science community and all others. So some people are focused, obviously, on data science research and methods, and taking data science as a profession in and of itself, while most, I think, scientific communities focus on their theories and on their principal issues and questions. And for them, data science is maybe an afterthought or a tool. And so I see a big gap there that needs to be bridged, I think.
Thank you. Related to that, one thing that I observe, at least in Finland, I think, is that in research, the funding models often focus on research activities, and it is much more difficult to get funding to develop and maintain infrastructures. And this is often like a little bit too separate. So it's different people than researchers who maintain the research infrastructures and develop that. If it's well done, it works well. But often you also need active input from the researchers to really make it work. And I think we should somehow get these communities closer, and maybe fund more research infrastructural work also in research teams and research organizations, so that we can little bit more align. I think this would help a lot already. Thank you.
And I might just quickly add something to that comment. So I sit on the infrastructure side and completely agree. And funding, to the level that's sustainable and still beneficial for users is not a trivial task. And it's a change also. So there's a whole change to how researchers potentially work that is not a simple overnight. You're changing the nature and best practices that exist in different research communities, and that's a difficult challenge, but really worth doing, I would say, from my perspective, and that really does bring the enduring kind of value in this space.
Yeah. So I did want to point out, a few of you brought up other communities that we kind of focused in on too, and I appreciate Leo talking about how even in those two there's fragmentations, and Daphne talking about the different sectors too, how those interact. But Daphne brought up the library community, information science, and how some of and wouldn't it be great if we had information scientists talking to marketing people so that the outputs were a little more coherent. But Kelsey, you also brought up the software community as another connector that needs to be included in some of this bringing communities together. And Padhu, you talked about the K through 12 sector, which I think is often forgotten. Do you want to say more about, do activities need to happen at the research or industry stage or university, or does it happen earlier where these things come together?
When you talk about K-12 and then say George Mason or UVA, that's the 4-year higher ed. And people often forget that there is 2-year schools in between, which is community colleges. And 4 years won't thrive without the 2-year folks coming in. So this is a very important group. So when we lay out pathways, they have to be in the game, actually. So, each one of those levels have their own respective organization. So while I was working with K-12, even though I'm in 4-year higher ed, we made sure that there is a statement that comes out of the National Council for Teachers in Mathematics about high school data science, how it should be taught. So that was a national statement that we had to, position statement that we have to create. But that didn't happen yet in the community colleges. And definitely, the organizations here that you're talking about, there's no, like, how should that be taught, or how should we be doing research? I know there is FAIR and other things, but I think that can be one way, creating these national position statements when communities come together to create something like that. The second thing, I know we are all in the US here, and I worked at the National Science Foundation, and now, they used to have 8 directorates, and slowly what is going to happen now, which I understand, is they're moving towards clusters. So there's going to be 5 clusters. AI is a cluster, quantum is a cluster, nuclear energy, believe it or not, is going to be a cluster, translational science is going to be a cluster, and the 5th one is biotechnology. Now, another way we can come together is to come together on these clusters. So if there is national priorities, if there's funding tagged to it, then the most important thing is for communities to agree on maybe using data as an important thing to address any of these clusters. That way we can come together also. So I can think of 2 different ways.
Okay, thank you so much for that. So I'd like to open it up to the audience to either comment or questions for the speakers. And if it's not too awkward, I'll run to you with the mic. I don't see any in the back, so I think, yes, I will be running to you. But don't let it deter you if you're in the back corner and you would like to speak. I am happy to go over there.
Thanks, Christine. I had to leave the room. Oh, yes. I'm Simon Hodson, Executive Director of CODATA. Thanks very much for organising this session. For a long time, I've been interested in the arguments presented in Phil's blog. I'm really glad that this session came about. I had to leave earlier briefly, so I hope I'm not repeating anything that's already been covered. But I'll just make a comment and share a view that one of my feelings about this topic is that it's really important, but the answer is that the data stewardship community needs to become more data science-y, and the data science community needs to become a bit more data stewardy. And what I mean by that is that certainly on the data stewardship side, we feel that we're still training some very high-level principles, data management plans, high-level discovery metadata, and perhaps I'm being unfair, but we wrote a policy piece last year as part of the World Fair project and CODATA, where we argued that it's really becoming quite urgent for a shift from what we called a bibliographic approach to data management, where you deposit a data set in a repository with some high-level discovery metadata, perhaps a README file, and we're still passing on all that work to the people that need to use it. And the fundamental challenge is how do we reduce that task of data wrangling? And to understand how to do that requires, on the one hand, a lot of data stewardship knowledge. What are the standards? What are the terminologies? What are the semantics that need to be attached to the data set at a fine-grained level, but also a certain amount of data stewardship, data science knowledge. How is this going to be used? And unless we somehow find a way of merging those skill sets in the people that are doing the data curation, data stewardship, data management, then we're going to keep passing the buck, as it were, to the end user. Likewise, one gets the impression, and again, I'm probably characterizing and being unfair, that a lot of the the data science education is, hey, here's some cool things you can do with Python, and here's how you can visualize and whatever, and a little bit unmoored, again, perhaps I'm being unfair, from the context, the provenance, the quality that went into the science. So I was very intrigued, and I'd like to follow up with Leo, who was talking about open methodologies. How will we characterize them? How are we passing on that information to the end user so they can judge how to use the data? And what Daphne said about data quality. How are we characterizing that? How can the end user judge that data quality? And I think that's an important part of the science and the data stewardship that needs to be embedded in the data science part of the curriculum. So I was mixing quite a few ideas there. I hope that made sense to people. But
Christine, can I respond to that?
Yes, please, please.
So one of the things that occurred to me even when I was the Chief Data Officer at NIH, which I tried to implement, which I think would start to be helpful to create more of a recognition and a synergy, is that when people use the data that in some way has been wrangled, that there's not ever any feedback loop. There isn't a Yelp for data. There's not, I don't necessarily say that's the answer, but there's no way, and I know this from running an international data resource, that the users very rarely report back the problems they find in the data. And that kind of virtuous cycle and how it comes about would actually teach the data engineers, let's say, more about how the data is being used, which would actually facilitate what they're doing. And ultimately, as the cycle goes round, the data would become more usable around this cycle. So, but that's never actually ever got off the ground. But it doesn't even seem to be metadata characteristics for describing what's happened with the usage of data sets. You know, and I've seen situations where, you know, two graduate students from different labs are talking. One spent a month trying to wrangle and do something with some data. They're moaning, you know, in the bar to their colleague down the hall, and that colleague has had exactly the same experience, and they never even knew about it because there was no reporting back on that data quality and that, you know, and the level of annotation, for example, of that data. So that, you know, there's a lot that could be done there, but there's been no national or international impetus to make that happen from the various stakeholders who would benefit from it.
Thank you so much, Phil. Yeah, I would argue actually the other proof of that is a lot of data science curriculums are built around data sets that are inherently filled with dirty data, and they never get cleaned up, even though tens of thousands of data science students are using that as an exercise of how to clean. That's the proof that, yeah, there is no feedback loop.
Thank you. I would continue on that a little bit with an example that we have currently. In Finland, we have a research project funded by the Research Council of Finland, where we collaborate with the National Library of Finland. And there the idea is to take the metadata about books that have been published in the last couple of hundred of years and then use this metadata for research. But this has been filled in by humans, and it is not really a systematic quantitative data, but it is like a historical process of filling in the metadata. It contains a lot of errors, different notations and conventions. So when we analyze it, we learn a lot about the errors or problems with the metadata, and we have been constantly feeding back to the National Library, and they are able to fix some of these things in their database, so it becomes better quality in the next iteration. And sometimes there is a logical explanation, and then we learn more about the data. So not all the inconsistencies are errors. Sometimes they make a lot of sense when we learn the explanation. And this is also my common experience in other fields like life sciences. So we work intimately with the data providers, and often it works best when we can somehow iterate between these two layers. But this really requires resources and the ability to communicate fluently with the other party. Thank you.
Okay, I'm coming to you, Amy. Okay.
Of course. Hi, Amy Nurnberger, Massachusetts Institute of Technology. I think thank you first of all for putting this program together, both from my role in data stewardship, also my role as an instructor on data management for education data, so coming from both sides of trying to teach this as well. But I think one of the elements in here that struck me as Simon was talking is we're talking about, you know, to your point of more data science into data stewardship and more data stewardship into data science. And I think the easy pathway there is like more data stewardship into data science, because we actually have data science curricula already, right? We have these elements, we have competencies, we are producing data sciences. As you said, Phil, there are all sorts of programs that produce data sciences. I think we don't have the same thing necessarily for producing data stewards. Where do data stewards come from? How do we actually operationalize that idea of how do we get data science into data stewards, when data stewards are just like, you know, a data steward, you can ask each one of them and they have a different background about how they got to data stewardship, so there isn't that single track that we see for data science. So I think this is, I certainly agree. More data stewards need to be conversant with what data science is and does and how it's expressed in different disciplines. But I think one of the challenges is okay, great, where do we do that? Because where do data stewards come from?
That is a great question. And Phil, I'm wondering, for your 900 and something minors, is there any room in what they're doing, right? That's only 6 classes, or?
Yeah, 6. Well, actually, it's 2 classes, 12 credits. Oh, no, 6 credits, sorry. But I was struck by a comment I wanted to make. In this life, many years ago, we founded a journal called PLOS Computational Biology. And as part of that, we started a section for biocurators. Myself included, but biocurators are the unsung heroes of biology and medicine, frankly. The Nobel Prize 2 years ago is a direct reflection on the work of biocurators. There's no two ways about it. But trying to get them to actually advocate for themselves proved to be pretty difficult. And so I think there's a role for the folks doing this kind of curation work to be better advocates. And I think, you know, now's the time, because I think there's much greater realization by the data scientists how important the work that data curators are doing. And, you know, so I think there's a much, which wasn't quite so apparent a number of years ago. You know, so I think getting that into the curriculum so that, and bringing in data curators to actually talk as part of the courses that are being given, and you know, and actually having courses that relate to that, because there's a subset of data scientists who want to go on and be data engineers and data creators and the rest of it. So there's opportunities there for career paths, which I don't think we're certainly not exploring to the point that, you know, that the folks come from all different disciplines, but there's really you know, I think within the world of data science, in a broader sense, there's an opportunity to create career paths for recognized career paths that have perhaps not existed before.
I just wanted to add a comment again from the infrastructure perspective. Something that I've certainly noticed, I'm quite biased, of course, this is similar to my path, but very often you have stewards and data managers that come through from the individual domains. You know, you look after your own research data, you find a passion or a niche or just a job opportunity that pops up. But I think having career pathways and having you know, the data stewardship and curation more embedded along the academia track would have a lot of value because that's realistically where many do step off that pathway. And it also leads to Simon's comment about that differentiating the bibliographic versus the data engineering aspects. And in terms of hands on the ground at the infrastructures, the biggest gap with skills is being able to connect the stewardship to the implementation technical skills, and that really bridges into that software space, the workflow space, the instrumentation space, and you have to bring together, in my perspective, the domain knowledge, that technical or application-specific experience, as well as the wealth of knowledge on the stewardship side, and then that's, yeah, hard to train on normal education pathways, of course, and have job opportunities.
Yeah, excuse me. I think that maybe one thing that we might be missing in data stewardship that might help it find its more proper position is a big problem. What is the big problem that a data steward is helping to solve? Okay, so for example, we understand that the big problem that a data scientist is trying to solve is that there is tons of data and we need to be able to master it and make sense of it. But I think we still don't have a concise definition of what is the major problem that a data steward is trying to solve. At least I don't have that clearly in my mind. And for example, if we take from another discipline that it's different from what we're discussing at this conference, but in my mind, for example, it's quite clear that information security, right, as a domain is a very big domain, and people who are dealing with security deal with important questions and big problems that we're able to verbalize, to define. And so we see in recent years the growth of a job that's called CISO, Chief Information Security Officer, in many companies. So in a sense, we're trying to say that a data steward should be the CISO of the data, right? So again, what's the missing link here to me is being able to define a strong problem, the solution for which is a data steward.
Yeah, maybe I can just support that by emphasizing also that the data stewardship is not really in isolation. It should be always looked in the context of a particular task. And I think the connection with the data scientists can help with that. So it is not possible to manage data without a clear goal. And I feel that there can be multiple different goals. So goal of a researcher can be very different from a goal of a public. And data stewards may serve both or many other purposes. So sometimes the data is being prepared for the circulation for the public, sometimes for researchers. I think this may have different needs, and you always need to think about that as well.
So we're at 12:59. We started on time. I think we should end on time, especially because lunch is next. But if we have one last burning question, or anyone wants the last word from the panel? Could go either way. I think it's looking like you, the panel, if you have something last to say.
I can say something, but I defer to the panel that's in the room.
Go ahead, Phil. Sorry, please. Yep, please go ahead, Phil.
I guess for me, it is the moment. I mean, we were talking about how, the fractionation issue earlier on across disciplines. I mean, we have a school that have got anthropologists, historians, computer scientists, biomedical researchers, economists, all under one roof. And the thing that brings them together and makes them excited is data. It's the notion that they have the opportunity to work with experts in different types of data to solve problems that they wouldn't solve with data just from their own discipline. And so with that underpinning, it seems to me that there's just huge opportunities to bring, and then of course it all relates to the quality of that data ultimately, which brings in the curators and all these important people. So I think it's an opportunity. It's a moment in time where there's huge opportunity. We should really try and grasp it as best we can.
Thank you so much, Phil. I think that's a good note to end on. Thank you, everyone who attended, and we'll let you get some sleep, Phil and Padu, and thank you to our presenters here as well. Thank you.